Yeah, I'm going to talk about this little programming model called scoped propagators that came out of a kind of accidental need for it. A little note, if I just add an asterisk to this. This is not the perfect name. It's kind of reappropriating multiple terms. This is not propagator networks, and it's also not really talking about scopes, so sorry about that. Quick bit of intro context. So like what this came out of is I was doing lots of different kinds of experimentation, and let's say, for example, you're messing around with like some composable UI stuff, right? So I have this environment where I can take a shape and snap it to a line, and now I have a slider. But it's like you want to show people that that's a real slider. So I'd often find myself doing stuff like this, making some little tool that could take a value out of this slider and do something with it, right? Put it somewhere else. And I realized after this came up a few times that there was a kind of a way to generalize this. And what that looks like is really two things. One is that we propagate values along edges. So like typically in node and wire stuff, you do this in nodes. Here we're having like single input, single output functions. So for example, we can take the rotation, we can take the width and turn it into a rotation. We can say, hello. We can propagate this through, add some stuff to the end of a string. Or if we change the color of this, we're going to kind of copy that color in one case and show it in text in the other. So the second half of this idea is that we scope the events that trigger this propagation. So the default here is that we have some on-change event. But we can also say that, well, when you click the target node, we're going to add an exclamation mark. Or we can come up with other events like a tick. So now every frame, we're going to get the current time, and we're gonna chuck it there. So what this looks like syntactically is we have this little propagation in the middle. You have a from and a to node. I only picked those terms because they're like the least number of characters, and you're going to have to type them a lot. So we define this event scope. And then what we're doing is we're defining a partial state update on the target node. So text, W and H, properties that exist on this shape down here. And we have access to the from and to nodes, and we can kind of do stuff with that. So actually, if we let's copy these out and replace this with an arrow. So if we do that, now we've made some kind of weird, pretty useless propagator there. All right. Couple of little caveats. This is not actually advocating node and wire programming. The hope is that it's kind of more embeddable in existing contexts, because like if you're on a web page, there's already like a bunch of rectangles there, right? It's hard to chuck extra geometry into existing user interfaces. These are not real propagator networks, sorry again. And it's also not really a general purpose programming model. It's really meant to be kind of monkey patching, glue, whatever you want to call it. So let's run through some examples. Let me also start a timer. Okay. So, I know. I'll come in under time. It'll be all right. So yeah, we can do simple stuff, right? You can turn a regular rectangle into a button. It doesn't know that it's a button, but now it's a toggle. Or we can have a counter thing, or we can make these layout constraints. They're not really constraints because they're only one direction. So we have all of this behavior here is just defined on these edges. We can also do things like geometric intersection, right? We can have values that propagate based on some kind of intersection and do weird fun stuff with that. With tick events, that gives you the ability to have smooth follow behavior, things like that. We can also, I'll get to this at the end, we can extend this with side effects if we want to. So in this case, we're making like a little rectangle tool paintbrush thing. It's also a very handy tool to just inspect things. So we can see the data down here because we're just stringifying some JSON, or we can do something silly like make this shape follow you around when it's blue. And yeah, we can start to kind of link these things together. So here we have a toggle, which is going to drive some system doing some weird math stuff that just kind of looks fun. What? Yeah, or we can do sharks. So down here we have this joystick, which is really just a rectangle, and we're just constraining some shape to it, and we're also pulling out the relative distance from the center of this rectangle. And then we have this fish and a shark with some follow behavior and a scoreboard and so on. And so if we hit toggle, it's a very easy game to win. It's actually lerping towards the fish, which means like if you're going at constant speed, it will just never catch you. But if you intentionally lose, we're now going to become a dead fish. It's the computer. It's not my fault. All right, yeah. So we have some asterisks. Oh yeah, I'm gonna be way under time. All right. So yeah, we can, if we want to, extend this with side effects. So I have this extra syntax of just adding some brackets. So if you wanted to go and send an email, do something out in the world, you could do that and then wait for it and get a value back. Another note is that you don't have to make this inversion of only doing compute on edges. So if I flip here, so here's a different context, right, where like we have these inputs being labeled A and B. We have, in this case, some LLM call that's using them. So you have some compute happening on a node, but then we're also using the edges to pull data out of that. So if I hit prompt, then we're going to see like this is going to pull the text out of that. This one's going to make it wider and show some useless information. So you can really like mix these two models together. A thing that I can't do yet, but I would like to, is that maybe we could start using this as a kind of way to glue actual apps together. So I have this little thing set up so I can doodle on my desktop, and I can also draw stuff onto Windows. And so if we chuck that in there, this is not using propagators, but let me just kind of give you an idea. We could do something like this, where we have some data coming in, and it will fail to paste. No one saw that. This is what live demos are for. Maybe it's the monitor. That should be pasting in a command. Usually that works. But you can kind of imagine a future where this already taken real estate of having a bunch of rectangles can be augmented with annotations like arrows also sound. Yeah, there's some open questions with this. One is bidirectionality. I don't know that this model will ever really be a good fit for that. I'd love to be wrong. Another is, whether this can work in a multiplayer environment. How do you spread out execution over multiple clients, things like that? And something I would love to do is generalize this to directed hyperedges. So one of the limits right now is that it's a single input, single output system. That doesn't have to be the case. There's nothing inherent to this model that makes it that way, other than I don't currently have a good way to actually interact with directed hyperedges. If anyone has ways of having good UX for that, come talk to me. Yeah, a little bit of future work. I want to try this out in a graph database context. It's kind of a natural fit there, right? You can imagine edges that take one value that's updated and propagate it to something else, doing whatever kind of transformation you want. I would like to try and do this as a kind of web page annotation layer. I think part of the thesis of this is that arrows make quite a good kind of annotation layer, like way to augment existing interfaces, because you don't have to deal with this problem of like finding space for extra UI, extra rectangles in there. That's actually it. I came in way under time. Here's some affiliations. That's the whole thing. There you go.